Hello, welcome to my demo. I'm Wayne Lam of CDS Service Data Solutions. Today, I'm going to show you the power of TDI, or Transparent Datapath Intercept. TDI is a very innovative patented technology. It is a foundation technology which we use to build our DMS, data migration server, and the DCS, data caching server. Products that are built on TDI has a very unique competitive edge. They can be deployed on a live fiber channel SAN without any downtime, and best yet, without making any changes to your hosts, your switches, or your storage. The appliances that are built on TDI can be inserted onto the fiber channel data paths while your application is running without any downtime. Our partners typically brings a pair of DMS or DCS appliances, power them up, and can perform the data path insertion at about 5 seconds per path. So in a matter of minutes, the appliances are in place, ready to migrate data or to accelerate your application while the applications are still running. No work is required on your hosts, the fiber channel switches, or the storage. In fact, we don't even need to ask you for the passwords to those systems. The implication is significant. This means we drastically lowered the risk of deployment by not making any host driver changes, zoning changes, or storage line masking changes. We eliminated the need for downtime, and the backup plan is simply to unplug us from the data path, restore your original path. We also avoided the requirement to have extra fiber channel ports. We're using the existing ports only. All the above features gives our DMS, DCS, and all other future products a significant competitive edge, which is the ease of deployment. Of course, each product also comes loaded with great features that make them very competitive in their respective fields, such as data migration, data scrubbing, data acceleration or caching, and so on. Behind me is a fully functioning fiber channel demo set. There's a whiteboard here that makes it much easier to see what's going on behind the whiteboard. So as you can see, there is a fiber channel host with 2 ports. The 2 path comes out and goes into the fiber channel switches. And from there, come out and go into a 2-port fiber channel source storage. DMS is what we're going to use to show the TDI for this demo. The DMS, in this case, comes with 2 nexuses, which I'm going to explain what that is. But basically, each of them is a pair of interception ports. There's an upstream port connected to a fiber channel wire with a coupler. And the coupler is just a plastic that allows another cable to then insert to it. The downstream port is connected to just a regular fiber channel wire. So with the insertion kit, it makes it a lot easier to perform the actual data path intercept. DMS works by taking the data path, let's say the one on the left here. Imagine data is flowing out of the host into the switch, come out and into the storage. We're going to physically intercept the path by feeding the data into our appliance through the upstream port, to the coupler, and then when it comes out of the DMS, back to the storage. So that's how we physically intercept. This works just like the answer machine in the old days. Remember the answer machine before voicemail? So you unplug the phone from the wall, you take that phone wire from the wall and plug it into the in port of the answer machine, and take the out port and plug it right back into the phone. So we're going to do the exact same thing with the Nexus interception kit in my hand here. Before I actually do the insertion, let's see how it works using the PowerPoint. The picture here shows the exact environment behind me. Here is the Windows host with 2 ports running IAMeter. We have 2 switches. Here is the DMS with 2 nexus, each with the insertion kit already installed. The kit consists of a pair of fiber channel cables connecting to the up and downstream ports of the Nexus port, plus an extra plastic coupler, or fiber channel cable extender, sometimes they call it, that changes the gender of the cable. With this kit, it is much easier to perform the insertion, which is done by simply unplugging the existing fiber channel cable from the source port. There it goes. Now I/O will be paused, and the multipath driver will start to retry on the path for up to 30 seconds or 45 seconds, depends on the setting. We then plug the cable into the plastic coupler. And then we take the other cable and plug it back into the storage port. And that's it. 1, 2, and 3. This typically takes only 5 seconds to perform. In all cases, I/O should resume within the 4 or 5 seconds it takes to do the insertion of each path. Now you do this one path at a time, and the risk is absolutely minimal. Worst case scenario is that if I/O does not resume within the timed out of 30 to 45 seconds, there will be an anticipated path failover to the other path, which we have not touched. The backup plan is simple. You just restore the original cable and plug it back into the original port. That's it. There are two basic modes of insertion. First, there is the host side insertion, which means we use the Nexus port to intercept the path right here between the host and the switch. Second, there is a storage side insertion where we perform the insertion between the switch and the storage right here, this segment here. Host side insertion is great for a large multi-tenant data center where a large pool of storage is shared by hosts that are belonging to different tenants. Intercepting at the host side guarantees compliance with separation requirements. The insertion only affects those hosts that are inserted and the associated storage that belong to those hosts. Now, storage side insertion is great for a scenario where you have 1 or 2 storage units being shared by many hosts in a private data center. For example, if one of the storage units needs to be replaced by a newer storage, and yet many hosts are zoned with it, then it's much easier to just intercept at the storage side, and whatever number of hosts associated with it are automatically intercepted. For this demo, we're going to use storage side interception. Here is the screen from the Windows host. Here's Diameter. Right now, it's generating somewhere around 1,000, 1,100, 900, so between 900 to 1,100 IR. But most importantly, the total error count here shows 0. What we want to do is to make sure that throughout the insertion process, which I'm going to do later, the I/O may pause for a few seconds, but the total error count should never exceed 0. Let's take a look at the GUI. All of our products are built on TDI has this Nexus module right here. Click and it's going to open. Here we show two Nexus, Nexus 1 and Nexus 2, corresponding to what we have in the demo board here. As I perform the insertion, these lights that are currently red, meaning they're not looped up or they're not connected, they will start to turn green. Let's do the insertion now. I'm going to move the screen to the right here so we can show the ports, and I'm also showing the Diameter running here. With the cable for Nexus 1 in my hand, here, upstream, downstream, I'm going to physically unplug the downstream fiber channel storage cable, plug it into the coupler, and then plug in the downstream port. And that's it. 1, 2, 3. That took a few seconds, and Diameter paused and resumed, and now the I/O has resumed. Looking at the Diameter here, I/O is running already back to the 1,000, 1,100, 900 IOP. But most importantly, the total error count here remains at 0. In the light at the DMS Nexus screen are now both green. Let's go to the GUI again and open up the detail, do a rescan, and done. So this now shows the discovered information. Here's the downstream storage controller's worldwide port name, and here's the upstream Windows box initiator worldwide port name. And the real-time I/O monitor shows the performance data with the IOPS and the megabyte per second. As you can see, we automatically discover all these complicated worldwide names, so you don't have to enter them by hand. Mistakes are avoided, and risk is eliminated. That's how easy it should be. So now, let's do the insertion of Nexus 2 using the second set of Nexus insertion kit here, upstream, downstream. Let's get diameter back on the screen. Okay, 1, 2, and 3. Once again, diameter pause for around 4 seconds, and I will resume. The error count stays at 0. The Nexus ports are green, and now if I open this up and do a rescan, it shows the automatically discovered information here, downstream storage controller worldwide port name, and the initiator host worldwide port name. I/O real-time monitoring graph is showing IOP to both the Nexus 1 and now Nexus 2. For all CDS software products, there is a SAN configuration module that shows all the hosts, switch, storage LUNs, and path that are automatically discovered. So open that up here. We show the automatically generated topology view. Here's the Windows host with 2 ports, 5-channel switches, 2 paths into a dual port storage unit that happen to be a NetApp device here with 4 LUNs. So the number of LUNs, their sizes, right? Each of these are 1 gig here. These are all automatically discovered. When the mouse over to any of the active element here, it will show the information for that element, including worldwide names, FCIDs for the switches, and so on. And if you click on each element, like this storage unit here, it will show the aggregated I/O in real time for that unit. So here it shows the megabyte per second, I/O per second, pending I/O, and response time. The pending I/O and response time are very important pieces of information for various CDS products. This is the true indication of how busy a disk or a port is. For example, the DMS product uses this to automatically throttle the migration. In a most conservative setting, data migration is suspended to yield to any host traffic. In other words, when there's any pending I/O from the host, we would say, hey, let's stop migrating. In this way, only the unused storage bandwidth is used for migration, thereby guaranteeing that your Oracle, your Exchange, whatever, will experience no impact at all. Of course, migration may take a longer time to do. And for DCS, the cache engine, it uses the pending I/O and latency data to measure which disk is challenged by I/O. So you may have a few hundred disks, but maybe 1 or 2 of them are the one that has the longest pending I/O list, and those are the ones that are slowing down the entire system. So by budgeting the appropriate amount of SSD or DRAM as cache resources for these 2 disks, the performance of the entire application is greatly accelerated. So with the least amount of cache resource, you get the best result. As you can see, TDI works wonderfully, making it possible to perform live insertion of the appliance onto the fiber channel data paths without any downtime. The automatically discovered information is a huge time saver in managing the resources either for migration or caching. But how does TDI do this so effectively and easily? Let's go to the PowerPoint again to get a better understanding of the TDI technology behind the scene. Once the nexus is inserted, it functions almost like a two-port fiber channel switch, which bridges the two endpoints as a virtual cable. The TDI driver will use the downstream connection to automatically discover the worldwide port name of the storage controller, in this case T1A. This worldwide port name is used by the upstream port to lock into the fiber channel zone, thereby connecting the host initiator data zone with it automatically. The I1A worldwide port name, for example, is then obtained automatically. So now, DMS can use the auto-discovered I1A to talk to the storage down here, and DMS uses T1A to talk to the host up there. Each host will resume I/O on the path. No path error is ever reported. From the host perspective, DMS looks like the storage. For the storage, DMS looks like the host. Therefore, DMS is transparent in the middle, just like a pane of glass. The process is surprisingly straightforward and is completely in compliance with the SCSI and fiber channel protocols. No proprietary gimmicks are involved. All commands are passed through verbatim by DMS, including vendor-specific commands that are sometimes used by specific vendor, even commands that are going to be invented in the future. We do not change anything. The host sends whatever fiber channel SCSI command, it will send it right down. And the result of those commands are passed right back up. It's not surprising to have DMS TDI being inserted in a totally unfamiliar first-time environment, and it will work the very first time. The elegance of this architecture makes TDI totally vendor neutral for all fiber channel switches, storage systems, and HBAs. So there you have it. The CDS Transparent Datapath Intercept, or TDI technology, enables all the CDS solutions, giving them the unique ability of being able to be deployed in a live fiber channel environment without any downtime and without making any changes to the SAN. Our partners and customers enjoy the benefits of avoiding all those planning meetings with the SAN switch owner, the host owner, and the storage owner all being in one place to discuss, propose, and making changes to the existing environment. Avoiding the design and testing of backup plans, and avoiding all the downtime that is often necessary to install appliances onto the SAN. So TDI simplifies the project to just physically insert the Nexus ports into your existing environment, taking only 5 seconds for each path to be intercepted. I hope you're impressed with the TDI technology in our DMS data migration server and DCS data caching server products, and all the future products to come. I look forward to working with you to try out this wonderful solution in your environment. Please visit www.cdsi.us.com for information and video demos for our DMS and DCS and other products that are based on TDI. Thank you.